Hi my friends, today we model this part which has the name Injector Restart Body. The drawing is here and it doesn't have any difficulties in modeling. Of course, if you respect what we learned together in my tutorials. We start with the external volume, this or this one, yes, external, which is obtained with the tool Revolve. Dimensions are here, dimensions are here at your disposition. I don't mention their names, their values. You will see as long as we model the part. This part is taken from Timoteo Carasoto drawings, and you can download it by watching the tutorial number 182. As you can see here. This is the assembly with this part number 1 and the detail is here. You see the part. I modified some dimensions in order to be more precise, and I added a projection to have all dimensions well placed. Okay, let's start. Standard millimeters IPT. First sketch, X-way plane, a line from the center point to the right with the value of 145. This is the axis, so that I make it center line. Then I draw some lines, 1, 2, 3, then restart from the other end, another one, you see I place it on the same horizontal or aligned these two. You see? Now I place here a circle, an arc with a radius of 30. The center is on the center line. Dimensions, this is diameter of 72, 40, this one together with the other from here, this is 67 diameter, and placement, this dimension is 8, this one is also 8, and the center is at 70. Now we have a fully constrained sketch so that we can apply Revolve to have the first volume. Now we take a look at the drawing and we see that this 67 is a square, not a circle. I can eliminate this from here because we have dimensions in the other projection. 76 and radius 10 at its corners. Let's create this square. I draw a rectangle, this one, I make equal these two sides, and I make tangent with this circle, external. Now we have this can be eliminated, and this is not important to be or not to be normal line. Finish sketch, extrude this face to the end of this, but not cut, join. Okay, this is to be filleted with radius 10 as well as the other three. Okay, next is this Stuts in German with dimensions taken from here. You see we have the diameter here. Timoteo has this dimension 26.5 for 3/4 of an inch, but I place here a more precise value, 26.441. We have to know this diameter in order to apply thread. You see dimensions here, 32, radius 3, 1247, 1.5. We don't apply the internal volume, only the external. Okay, the plane is XY. F7, we project this arc to have the center for the center line with the length of 47. We go to the left, up, right, up, left. I keep pressed the left button and I go somewhere here, and then here to be tangent. I apply tangency here. These are equal. I move this up, then dimensions, but let me make this center line. Dimensions 26.441, 27 is this. Let me move the center to have a proper arrangement. This is 1.5. 25 is this. Radius 3 for 1 to both. This is 12. And another one dimension is 32. This fully constrained. I draw an arc from this point to this point with this radius. Finish sketch, revolve, and we have this construction. We apply here a chamfer of 1 millimeter at 45 degrees, and to not forget 3 millimeters outside. We have 3 also inside, but I want to be sure with this. The other feature is this one, this, or better we see it here, this flange with these dimensions from here. This is 70 diameter, 8 millimeters, placement at 125, and this diameter, which is here, 30. Okay, same plane, F7. We draw a line from here, 50, placed at 125 from here, with this end point on the same horizontal, this point, with a center point and a line which is a center line. Then lines. 1, 8, we go here and to the center line. This dimension is 30. And this one is 70. Finish sketch, revolve. Now you know the procedure. You start with external volumes and then internal. I don't want to forget to place here 3 and also here 3 as a fillet. Now we have an internal volume, revolution volume, which is this one, for the start with the internal volumes. You see a lot of dimensions here, but important is this center, because we have to place radius 25 here. You see 30 is this dimension, 30 is this dimension, and also this short one, as well as this. Yes? So we have to use this plane, new sketch, F7. I project this face because I draw the axis of the revolution. This is the axis center line. Then we draw lines, as you also know. I go somewhere here, down, up, down, and somewhere. Another lines starts from this point then to the left, down, left, down, left, down. I go here somewhere, this, and inside the arc. I project this arc, I make it construction, and I have this point. Arc from somewhere here to somewhere here, why not? And the radius of 25. The center is coincident with this center. I placed that dimension 30. This is 1, 30. You see this is aligned with the other one, and also no, this with this, so that I place dimensions as in the drawing. This is 30, and now trim this, and this. Other dimensions. This is 2 millimeters. This is 3. The right vertical is at 30, again 30. Here, this is 8. This is 20. And three, and this 20 has this center on this mid center. I project this and I apply on the same vertical this point with this center point. Yes? Okay. Now diameters. This is 35. 35. This is 30 once again. This is 22 and this is 20. Good, good. This is 25. 25. This is 35, and what are the other? Let's see. This was not perpendicular. Apply. Done. Now I take a look. This is horizontal. This means that this is not vertical. And the other dimension is here. Well, I apply here 95. 95. Now we see this is not horizontal. I cut 95 and I make this horizontal. It must be on the same horizontal with this. I keep here to see the curve because I want to place collinear, this line with this line. It is aligned, but I didn't see that the sketch is fully constrained. Yes, that angle included 2 dimensions, not only 1. Okay. 90 here, and we still have a missing dimension. Oh, this is parallel with this. Now they are parallel. This was sloped. Fully constrained sketch. Revolve. With cut. Okay. Now we have inside here many fillets. They are mentioned in the note. The value is 3. This is 3 and this is 8 because the difference between radius 25 radius 3 is 5. This is the thickness of the wall. The other are 3. Okay, to make this I apply view, half section view on this plane. Now I apply fillets. Fillets, here is 3. Here is also 3, also 3, also 3, plus 8. 8 are these two edges, you see? Okay, now I can go back to disable this section view, half section view, and all we have now to apply are holes. Now we apply 2 holes, this one 20 and this one 20, from the face to the mid plane, this mid plane. We don't forget that there is a radius of 8 here. Okay. Hole. This face, this center, 20, and 2 plane XZ. Okay. The other one, this center, this face, this center, and select surface, also this plane. Okay. Then this fillet of 8. Okay. There is a fillet there, this one, which is this one, you see? Oh, this is this from inside. Good. Now holes. This are these 4 holes of 7 at a circle of 50. I select this face, I draw a line, a vertical line of 50 divided by 2. Then a hole placed right here of 7, not 20, and the face is this, you see? Okay. Circular pattern of the last feature about this center or axis, 4 instances. Okay. Next is this with the 58, the circle, also 7 millimeters diameter, and placed at 45 degrees. Line from this point at a distance of 58 divided by 2, tab 45. Finish sketch. hole, this point, 7 is okay, surface for finish is here. Again, circular pattern for the last feature about this axis, not 6 but 4 holes. Good. Here is simpler, but the hole is 8. You see, 8. Simpler because I select this and I have points. I can modify the status of these points. I keep pressed the shift button and I apply this tool to make them center points for holes. Hole 8, not 7, to the surface, this surface. Okay, and we have all 4 holes without circular pattern or other things. That's all, my friends. It is finished. Okay, but now I see that this is too large. Let's measure it. M from mic. This distance must be 67 and this is 72. Why? Because I selected this diameter instead of the 67 one. No problem. We go to the sketch, double click, and you see the 2 diameters. I have to place this tangent, not this tangent. We have tangencies. I delete the constraint tangent to each side. One is missing because this is a square. Tangent this face or side with this internal circle, and this is resulting. Finish sketch. Now it is smaller as well as the diameter of the center. All we have to do now is to see what is the volume. High properties, physical, update, copy, close, drawing, volume, double click and paste. Well, 39 and this is 40. The 4th digit is different. We apply the last value as good for us. Then the material is steel carbon. The color is olive green and some faces must be machined. I select some of them. You can select any other one at your will. By keeping pressed the left button of the, not the left, the key on the keyboard, Shift pressed. All this to be steel carbon polished. Okay. Oh, this is not. This is a thread. Let me apply the thread. I forgot it. Yes, and you don't say anything. This is to be cleared. Clear override for this. And now I apply thread on this as ISO met pipe threads, gas 3/4, 26, and that's all. It was another mistake. Okay, my friends, that's all for today. Thanks for watching. Bye bye.